Hello and welcome to Math200 Statistics Online here at Cañada College. My name is Lapuz. In this video, we will take a look at homework from section 4.3. This is problem number 4. In this problem, we're given the information that there's a box that contains 5 cameras, or 8 cameras, and 5 of them are defective. A sample of 2 cameras is selected at random with replacement, and they want us to define a random variable x to be the number of defective cameras in that sample of 2 cameras. So what are the possible outcomes for that, or what are the possible number of defective cameras we can get? Well, those are the x values. That's the random variable in your probability distribution. And you can either have 0 defective cameras, you can have 1 defective camera, or you can have 2 defective camera. You can't have any more than that because your sample goes only as far as 2. So now that you're given this, if you select the 2 cameras, what's the probability that 0 of them are defective? Well, out of 8 cameras, there's a probability that 5 out of 8 of them will be defective. So we can say the probability that we're going to be looking at is going to be 5 out of 8. And so that 5 out of 8 actually, incidentally, is the probability. By the way, we know that this is a binomial distribution. And in a binomial distribution, there are 2 parameters that are needed. So your x random variable is a binomial distribution, and we need to identify n and p. So it looks like we have p identified. So now let's figure out what n is equal to. N is going to be the total number that you have, and so since we're only selecting 2 cameras, your n is going to be equal to 2. Now, we can fill up this probability column by looking at the probabilities of selecting 2 cameras, which could be easy enough to do, but these probability distributions sometimes, or these binomial probability distribution problems, sometimes have large number n. So in our simple example here, n is just equal to 2, but sometimes n can be whatever number, 30 or 100 or whatever it might be. And so what we're interested in is to use the binomial probability aspect of things. Now, if you go Google binomial distribution calculator or something like that, you'll see a bunch of calculators that you can fill out. You can also do this using the actual TI-84 calculator, but in this scenario, we will use Google Sheets. And so I have a table set up. So what we want to do is we want a table that has an x and a p of x. And then under the x, we're going to have our x probability distributions. And it always starts with 0 and will end at whatever the n is equal to. For example, if n is equal to 10, I want to fill up this column, random variable column, where it's going to be 10. And there's some small instructions here to highlight the 0 and 1 cells, and then click and drag as many as whatever n is equal to. So I'll highlight 0 and 1, then I'll take this dot, I'll click and drag that to, this only went up to 8, let's go up to 10. So this is as far as we would go if our n was equal to 10. But in our problem, our n is only equal to 2, so we don't need the rest of this. So let's just take away these other ones. And then let's just fill up this table from 0 to 2. All right. So we put in our value for n, which is 2 in this case, and then our value for p. Now, if we put 5 divided by 8, it's not really going to look at that as a value. So in Excel or in Google Sheets, what we need to do is, it actually looks at it as a date. We want to say equals, and then we want this to do the calculation of 5 divided by 8. Okay, so press enter, and I think at this point it's slated as a date, so we don't want this to be a date. We want it to be a number, so let's make it into a number. And then 5 divided by 8 is going to end up being 0.625, and so when I press enter, it looks like it rounded off, but let's see, we can click and make this a little bit wider, or maybe we can extend the number. Oops, maybe I need to highlight this and extend the number of decimal places we want. All right, so this is rounded off to 4 decimal places. Okay, so now when n is equal to 2 and p is equal to 5 divided by 8, these are the values that we get for 0. So where do these values come from? So if you click on this, you'll see that the actual command or function that we have is binom.dist. And binom.dist looks for an a value. You can type that in yourself here and find out. It looks for an x value, and then the next number is n, the next number is p, and then the last number is actually it's a binary true or false. We could put 0 here, or we could put 1. 0 for false, 1 for true. But I typed in the word false to ask if this is a cumulative distribution or not. So the first value is the number of successes, then the number of trials, then the probability of success, and then the cumulativeness. So the number of trials is n, and that's why it has this. I'm going to click and drag this, but I want this to be fixed at this cell. That gives a number 2. That's why there are dollar signs there. And then the next one is fixed at this cell to get the probability. That's the calculation of 5 divided by 8. And this number here is the x value that we have. That's the number of successes that we're counting. Okay. All right, so we can press enter for that, and then what we need to do is we need to highlight that and click and drag again to get these other probabilities. So this would be your answer. Now sometimes they might be asking for the cumulative distribution or cumulative probabilities, and so the only difference between this cumulative probability and the other probability is that if it's cumulative, it's true, which means you're going to add up all those numbers before. So since there are no numbers before in this particular scenario, I think I added an extra term here, so let me delete that. So since there are no numbers before, it's going to be the exact same value as the first probability that we got. But now when we click and drag, what we're going to see is the next number here is going to be the sum of 140625 plus 0.46875, and we get this number here. And then we know that in probability distributions, when you add up all the probabilities, it should equal to 1. So every time you do this, your last number in this cumulative probability column should always equal to 1, because you're going to add up all these numbers in the actual distribution. All right, so I think that will be our results. So let's set this aside and copy these numbers. Actually, I'll put that here, shrink this a little bit. And then our values rounded off to 2 decimal places is 0.14, 0.468, so that's I'll call it 69, or I'm sorry, call it 68 would be rounded off to 7. And then the last one is 0.39. And just to make sure, we should add up all these numbers to make sure that these things add up to 1. So this is 11 plus 9 is 20, carry 2, This is 7, 8, 9, 10, so that's 100% or 1, and so that is our value. Okay, all right, now in this next question, we don't really need a calculator much for this. They want us to find the expected value. We know the expected value is actually a mean, so we want expected value. This is actually the mean, and the formula says that expected value for a binomial distribution should be n times p. All right, and so this is n, this is p, so this is just 2 times 5/8. So this is essentially 5/4, 1.25. And so this value here should be a number between 0 and 2, and 1.25 weighs a little bit more between 1 and 2, and so we can kind of see that that kind of makes sense. All right, this is a long-winded explanation. It's a lot simpler than the length of this video, so I hope you're able to pick this up and be able to do this problem. Okay, good luck.